Okay, so last night we talked about ratios, all right, and just to review real quick, remember when it comes to representing ratios, we have three forms, all right. Our ratio is nothing more than comparing two numbers, so if we wanted, we can represent that in this form with a colon. We can represent it this form in its fraction, and if we're in a sentence or in some kind of a story problem, we may see the little word to as a part of that. Most of the time, fraction is the one we want to make sure we use because we end up having to do some other work or reducing to lowest terms and things like that. So we always want to that's probably the one you're going to use the most, but we need to be aware that there are three forms. Okay, so ratios. All right, so if we look at the two rectangles that we got sketched out here, all right, we want to see which one of these has the greatest ratio. The greatest ratio of length to width. Okay, so that's our question. Which one of these rectangles has the largest ratio of length to width? So we need to get them both represented first. So if we first rectangle here, rectangle A, we would say has a ratio of 15 to 7. Length first, width second. Rectangle B has a ratio of 18 to 3. So we have them represented, but we still really haven't answered the question, which one has the greatest ratio? So we probably just need to go a step farther here, recognizing that since we're using a fraction bar, that also means we can divide. All right, so 18 to 3 has a ratio of 6. 15 to 7, and again, we can divide here. All right, that would be very quickly 2.1. And again, we could continue this, but we obviously have enough information here to recognize which one has the greatest ratio of length to width. All right, and that would be rectangle B. All right, the length is 6 times greater than the width. The length is 2.1 times greater than the width. Okay, so yeah, this one we could even say, if we wanted, we could say 6 to 1. This one would be 2 to 1. So rectangle B has the greatest ratio there. All right, so that's one way we can use ratios to compare. We could also have to do some conversion with our ratios. All right, so for example, we might watch an ant that's crawling across the ground, and that ant may travel at a distance of 6 feet per minute. All right, that ant may travel at a speed of 6 feet per minute. So the question might be, how fast is the ant in miles per hour? All right, how fast is that in miles per hour? So again, we can set up a couple ratios here. 6 feet per minute, 6 feet per 1 minute. Okay. Actually, miles per hour is probably not going to be the best choice here. Let's just rewrite that as feet per hour. So our first ratio is 6 feet per minute, so we can represent that as 6 feet per 1 minute. Again, that little word per right there is your reference to the fraction bar. All right, and that can help you what goes on top, what goes on bottom. And now it wants to know how many feet per hour. All right, feet per hour. All right, so since we're talking 1 hour. All right. So that's the question. So we can use ratios here. The other thing we may be thinking is, how long is an hour? An hour is 60 minutes. All right, 60 minutes. So we know if we can go 6 foot in 1 minute, we can just do a simple multiplication. and we can come up with 360 feet in an hour. All right. So again, we can use simple multiplication there, or if we would like, you can use your ratios to help you get things clarified to set up. But again, that can help you get started there. That can help you get started. Okay? So that was your ratio homework last night. Do the best you can. Bring any questions you have to class tomorrow. Have a good night.